Next section is the second example is laminar pipe flow property. The flow rate Q of the cone setup through the horizontal pipe shown in below figure. This is figure A. To be the monitor by the measuring the pressure difference between section 1 and 2. So this is a section 1 and 2. Measure the pressure. It's proposed that the Q is equal to K delta P, where the calibrated constant K is a function of temperature T because of the variation of the syllabus, because the density and temperature. These variation are given in the table. So this is table for the variation between the temperature, density, and the dynamic velocity for the cone setup. Okay. The first thing, plot the KT is a versus T for the range of temperature, and the second is determine the wall shear stress or tau W and the pressure drop delta P for the Q is equal to this number and T is 58 degrees C, and C is for the condition of the part B, determine the net pressure force FP and the net shear stress FV on the fluid within the pipe between the section 1 and 2. Okay, for the pressure force, FP is come from the different pressure between two section and time area. So that is the equation for FB. For FV is like the viscous force, or is a shear, the shear stress is come from the wall shear stress times the circular area, circular length around the cylinder. Okay, that is 2 pi RL. Okay, on the circular surface of the cylinder. Okay, we start from part A, laminar flow. We bring the equation 6. In this equation, we substitute the number in here for pi and d. Diameter of the pipe is 7.6 centimeter. Delta P and divided by, we don't know the viscosity, and for L is 1.8 meter. Okay, in this case, the delta P is in terms of the, okay, unit of delta P is the Newton per square meter, and for the unit of dynamic velocity is Newton sec per meter square, and unit of Q is the meter per second. Okay, so we can derive equation of Q in terms of the constant K and P is equal to constant 4.5 10 power minus 7 and delta P divided by mu. So in this case, K is equal to 4.5 10 mu. Okay, and units is the meter power 5 Newton sec for K. And we can plot the curve like this. We just to find the viscosity from this table. I can from different from 15 degree to 71 degree and put the viscosity in this equation and plot the curve between T and the K. Okay, based on this equation, we can prove that this is controlled by pressure or viscosity. In this case, its law is not included. Because in the shear force is not important. Okay, in this case we can bring back that if three if we can find from the temperature, we can find the viscosity, and from viscosity we can find K. Okay. And the second part, for part B, I finished the draw the curve at the T is 30x 30x degree C. We can look at the table to find the mu. Mu is 1.8 10 power minus 1, and given Q is 1.4 10 power minus 2, and from equation 6 we can find delta P. Okay, delta P 128. Okay, we just substitute the number in this equation. Substitute the viscosity. Substitute the length and Q. Okay, and divided by pi, and diameter is 7.6 convert to meter. Power 4. 5,540 Newton per square meter. That is the pressure, different pressure. And next we apply we can find Q, velocity, Q divided by A, area. We found that the velocity is 3.1 meter per second, and we check Reynolds number is equal to low VDO mu. From the table, for 48 degree, okay, density is the 1056. This is a viscosity. So we put density times velocity times diameter divided by viscosity. So it is 1,300, and so we prove that is the less than 2,100 is the laminar flow. Okay, and that's part C. Okay, we not finish part C. We have to find what is the shear stress, wall shear stress. From equation 3, we can wall shear stress is the delta P times diameter 4L. So we can substitute delta P 5,540 times diameter times the 4 and length. So we got 58.5 Newton per square meter. That is the I think it is part C. Okay, that is the that's for the wall shear stress. And we move to part C. The pressure force is equal to pi over 4 d square times delta P. Delta P is 5,540. So FP is 25 Newton. And for FV is the if its radius is 2 pi r. Okay. Diameter divided by 2 and times the length times the wall shear stress from the at the top, 58.5. So we got 25 Newton. You can see that if FP is equal to FB, prove that net force is 0. So y acceleration is 0. Okay, that is solution for this problem.